Bismillahirrahmanirrahim. Hello everyone, this is me Asad Belokman, and today we have a presentation about Navier-Stokes equation. And today we will talk about a law of it, type of fluid in this Navier-Stokes equation, also example analyze of this equation. Navier-Stokes equation. We're gonna start to talk about Newtonian fluid constant. We will start to talk about density, also viscosity. This is the first things we will talk about it. What is the law? What is the important these 2 points in the equation? The second one, Cartesian, cylindrical, spherical coordinates, and what is the difference between each one. Right now we're gonna start to talk about the analysis of the equation. For a viscous flow, the relationship between the normal shear stress and the rate of deformation, velocity, flight variation can be determined by making a simple assumption, that is, the stress are linearly related to the rate of deformation. Newtonian fluid. The proportional constant for the relation is the dynamics of viscosity of the fluid. Based on this, Navier-Stokes derived it's famous by Navier-Stokes equation. And you can see right now in the screen how the analyze of it, like it's all of it start with the density and all this, how to can get the equation of Navier-Stokes equation. And right now we're gonna start to talk about one of the most important point in the presentation, physical law. The first law we have it is spherical coordinates. Here we can, as we see the law in the screen, we have in this law uh, density, volume, time, viscosity, and also gravity. The second law is continuity, and also in this law we have density, volume, time. Newton's law of viscosity, we have in this law volume, density, viscosity, all this same, the first two. Navier-Stokes equation. Example, we have some example in our life, like ODE phase, BDE, spherical and cylindrical coordinates, equation for wave flow between rotating cylinders, and also then film with temperature. And this the number 4 and 5 we cannot do it at the class, it's from out of our subject. And radial flow between circular plates. Guidelines for solving BDE in momentum transfer method. A problem involves finite scales. Spreading of variable method should be tried. And the second one, a problem involves infinite or semi-infinite distance comparison of variables method should be also tried. Right now you have to focus in the screen so much. You will find two examples I put about about two problems how you can find the equation from it, and it's with the solution. The first one is Navier-Stokes exam, for example, state for flow in rectangular channel, and the second one in rectangular also is a channel. And you can see in the solve of it there is five equation. How you can find it? By you can say Vy volume y equal volume z equal 0. And also you have to find, this is the first point. The second one, you have to find volume x, integration of y and z. And gravity has no competence in extraction. And if you focus do it, it's so easy. And where it also will explain the note. Note 1, check that above solution is a forward, it's a followed practical solution. Before trying to get the general solution, write down the boundary of condition for over solution Vx. Before you finish to answer, you have to write all the question what you got, and to get the last question you have to compare it with all to get it. Finally, thank you so much for listening to me, and I hope you understand everything. If you have any question, you can ask me.